So let's do an example. What's the Laplace transform of t cubed? 1 over s to the 3 plus 1 times gamma of 3 plus 1. Do we see where that's coming from? A is equal to 3 in this case. A is equal to 3 in this case. So we've got 1 over s to the 3 plus 1, gamma of 3 plus 1. Remember what the Laplace transform does. It takes as input a function with t's in it, and it outputs a function with s's in it. That's what your gamma function does, or a Laplace transform does. Takes a function with t's as input, outputs a function with s's. Again, I get that you don't care about this for differential equations yet. I totally understand that. If we simplify, this is going to be 1 over s to the 4th, gamma of 4, right? And then if we use our gamma of n plus 1, this is going to be 1 over s to the 4th times 3 factorial, or 6 over s to the 4th. So we've got 6 over s to the 4th. Daniel.
So you use the gamma function in like a subset of Laplace transform cases when you're taking t to the a.
Yep, so if you want to look at t to the a, then you are going to have, and I have a general example of why this works in my notes, I'm just doing a specific one here, but if you do the Laplace transform of t to the a in general, the definition ends up having the gamma function in it. You can kind of see that, right? Like here, the Laplace transform of a function has an integral with an e to the negative st and f of t. And here the gamma function kind of sort of has some of that same stuff too, so it makes sense that they would be related. Kind of, sort of. So you need the gamma function in order to do some specific Laplace transforms. That's where we're at. Okay, I'm going to pause here. I'm going to stop sharing my screen so I can see all of you. Grant has his hand raised. What do you got, Grant? Or you don't for real? Okay, then I think I can lower your hand. Yes, I can. How are we doing up to this point? Gamma functions, Laplace transform. So think, here's your basics. Laplace transform takes as input a function with t and outputs a function with s. That's your basics for Laplace transforms. Takes as input a function with t, outputs a function with s. Doing okay? That's your basics. And then there's this really messy definition for how we evaluate Laplace transforms. All good? Basic ideas, we're doing big basic ideas, and you can go back and look at the details in the notes. Big basic ideas, yes? Helpful? Yes? All right. This is not productive. This is not productive in terms of finding all of these by hand. It's like doing derivatives by the limit definition. So here's what we have. Okay, this is in the, this is in the front of your textbook. It's right inside the front cover of your textbook. So it tells you what the input is for a Laplace transform, and it tells you what the output. This is our general notation that we just did. F of t comes as input, and then capital F of s is our output. So this is what we just did. We did the 1 right here. So my input was 1, and we got 1 over s, right? We did that one. That one worked. We did t to the, they did n, and I'm doing a. So here's t to the n, and then we got that n factorial. That's the gamma function of s to the n plus 1. So you are going to be very, very, very familiar with this chart as we go through chapter 4. Okay, it's in the front of your book. I also did post it as a handout on Moodle. So it is available on Moodle as a handout, and you can see stuff. There's a couple of really nice properties that the gamma function has. And again, there's a proof of this in my notes so you can see where they're coming from. The first is that it's what's called a linear operator. So in here, let's see if I can do this with a comment. I think I can. So the gamma function is what's called a linear operator. Oh, no. Nope. Okay, giving up on the comments. I thought I could write on a PDF and I can't. Go away. So because we have a f of t plus b g of t, we can say that's a times the first one plus b times the second one. You can do functions independently. It's exactly like derivatives, right? Think of this like a derivative. If you did the derivative of this whole thing, it would be a times f prime plus b times g prime. I'm saying I can do a times capital F of s, b times capital G of s. It works exactly like the derivative when you have addition, okay? So here's what I want you to do. take a minute looking at, we'll go back to whiteboard, and I'm gonna have you work through one and we'll see how this goes though. So let's go here, we're gonna do new screen. All right, so here's the thing you wanna remember. The Laplace transform of t to the a or to the n is, sorry. Let's do t to the n, where we have an exponent. T to the n is n factorial over s to the n plus 1. That's in the front of the book, if n is an integer, because I have the gamma function. Do for me, please, the Laplace transform of t to the 4th plus 4t squared plus 2. Take a sec, work that one through. Again, we're trying things here. This is my very first lecture via Zoom. It's fantastic. What's the Laplace transform of t to the 4th plus 4t squared plus 2? Laplace transform of t to the 4th plus 4t squared plus 2. I'm going to stop sharing my screen so that I can see all you guys working on this, and then we'll come back and work it together. Laplace transform of t to the 4th plus 4t squared plus 2. Laplace transform of okay. Raise your hand when you have an answer virtually would be good. Do a virtual hand raise when you got an answer, and we'll see how this works. Cool. If you get stuck, that's totally fine. We'll go over this one, and then I'm going to do another one for you. Okay, we got a couple going here. Do a virtual hand raise when you got your answer. Or a real hand raise. You can do a virtual one if you want.
I don't know, how do I do a virtual hand raise?
So along the bottom of the screen, if you click on participants, there's a bar that'll pop up. And then I think there's an option to raise your hand in there. I don't show the same, I don't see the same thing that you are because this is my meeting. There you go. Yep, you got it. So this is also an exercise in figuring out your virtual hand raise. Cool. I'm gonna give it another 15 seconds or so. Awesome. Couple more still working, that's fine. Okay. All right, so going back to my whiteboard. Katie, what do you got for an answer? Brave, volunteer, unmute yourself, and tell me what you got. Maybe. There you go.
So I wasn't sure, but so I have 4 factorial over s4 plus 1.
Yep, so we can say s to the 5th. That's totally right. Keep going. Good. And then the 4 stays out in front, so 4 times.
Yeah. 2 factorial.
Absolutely.
Over s to the 3rd.
Yep. And then one more. 2 times. What was our Laplace transform of 1 way back from the beginning of class? Our Laplace transform of 1 way back from the beginning of class was?
Just 1 over s.
Absolutely. So if we want to, we can rewrite this as 24 over s to the 5th plus 8 over s cubed plus 2 over s. And again, in terms of the domain, this is for s bigger than 0. So there's your Laplace transform. I'm lowering everybody's hand, by the way. Maybe I can't do that. That's okay. Okay, I want you, are we good? Everybody's good so far? Making sense on that Laplace transform? Okay, here's what I want you to do, and I'm going to divide you into breakout rooms because we're going to try 2 of these, and I think you're going to be maybe more comfortable talking about it with each other, but we'll see. So try 2 of these. First of all, try for me, please, the Laplace transform of 1 plus t quantity cubed. You're going to want a FOIL for this one. Laplace transform of 1 plus t quantity cubed, and then the Laplace transform, and you're going to need your front of your book for this, of t to the 3rd minus e to the negative 10t. So I want you to try those 2 for me. Laplace transform of 1 plus t quantity cubed, and then the Laplace transform of t cubed minus e to the negative 10t. This one you're going to want your book for, or that handout that I had on Moodle, or I'm going to drive you into breakout rooms so somebody can hopefully pull it up in your room. Everybody got both of those problems. Laplace transform of 1 plus t quantity cubed, and the Laplace transform of t cubed minus e to the negative 10t. Okay, I'm going to stop sharing my screen, and I am going to do breakout rooms. I'm going to put you back in the same ones that you were before because that's the easier. So we're just going to open all rooms. You got to go ahead and join your breakout room. You should have gotten an invitation. So we'll do this maybe, I don't know, 5 minutes or so. So go ahead and join your breakout rooms. People are starting to leave. That's great. And I'll pop around.